You're welcome to this morning's Signpost webinar. I'm Mark Gibson and I'm head of the Teagasc Outreach and Innovation Department. This series is brought to you by Teagasc in collaboration with Dairy Sustainability Ireland, the National Rural Network and Food Drink Ireland SkillNet. And I'm also joined by Padraig Foley in Johnstown Castle, who's going to be helping us with questions later on. Good morning, Padraig.
Good morning, Mark.
So this week we are celebrating Bioeconomy Ireland Week, which is an annual week-long event held each October to highlight and raise awareness of Ireland's rapidly growing bioeconomy. So what is the bioeconomy? Some of you might be asking. Well, the bioeconomy is the part of the economy which preserves nature and uses renewable biological resources from agriculture, forestry, marine and organic waste systems to produce food, feed, bio-based materials, chemicals and energy, and while reducing waste, all in support of achieving a sustainable, circular and climate neutral society. And today we'll be discussing a new innovative project called Biorefinery Glass, and we'll also be discussing the potential of the bioeconomy to transform grassland agriculture in Ireland. And to tell us more about the project, I'm delighted to be joined by James Gaffey, who is Director of Circular Bioeconomy Research Group at the Munster Technological University, Dr. Bridget Lynch, who is a Senior Research Officer with the Environment and Soils and Land Use Programme with Teagasc, and Professor Johan Sanders, who is former Professor in Bio-based Economy at Wageningen University in the Netherlands. Good morning, everybody.
Morning, Mark.
Morning.
Morning, everybody.
Very welcome to the Signpost webinar. And perhaps, Johan, if I could start with you and maybe just to introduce yourself and maybe tell us where you're coming from this morning.
Well, I live in Groningen, in the northern part of the Netherlands, and I keep myself busy with bio-based economy projects like Glass biorefinery, which I will comment on today.
Great, thank you. And looking forward to your presentation later, Johan. And James, if you could tell us a little bit about the work that you're doing down in MTU.
Yeah, so I co-lead a research group in bioeconomy. We're about just over 15 researchers working on different research and innovation actions, all related to the bioeconomy. We're also involved in the education side. We co-deliver Ireland's first master's program in bioeconomy alongside Teagasc and University College Dublin. And I suppose I've been based in MTU and formerly IT Tralee for the last 5 years and have worked for 7 years in industry before joining academia on the bioeconomy side.
Thanks, James. And Bridget, you're not too far away from us in Teagasc. You're down in Johnstown Castle. Can you tell us a little bit about the work that you're doing there?
Yeah, so I joined Teagasc in January of this year. I'm working as an agronomist, predominantly in the agricultural catchments programme, but also working in other projects in the Environment, Soils and Land Use Department. Prior to that, I was Associate Professor of Grass and Science in UCD, and that's where I was involved in the Biorefinery Glass project. And I continued to work with James and Johan through the Farm Zero Z project, which we presented last week, and other initiatives.
Thanks, Bridget. So we're going to have 3 separate presentations this morning, all around 10 minutes long. And so if I could ask James, you're going to kick off the presentations for us, if you could share your screen with us. And just while you're doing that, James, we just want to remind everybody that there is a Q&A tab at the bottom of your screen. Please do send us your questions at any stage, and we'll endeavour to answer as many of those at the end of the presentation. And today's webinar is being recorded and will be available on the Teagasc website afterwards, along with the presentation. And you can also tune into the Signpost webinar, the Signpost podcast, if you are not able to get to a screen. And just to give a special shout out to Patrick Barrett, who is in the Department of Agriculture. Patrick has been driving the whole bioeconomy agenda within the Department of Agriculture. And thanks to Patrick, we have all of these fine presenters today. So James, we can see your screen fine there. If you want to maximize it there, and we'll let you, you can continue there.
Thanks, Mark. Morning, everyone. So I'm going to talk and introduce the Biorefinery Glass project. It's one of the EIP Agri projects, and it's funded by the Department of the Agriculture, Food and the Marine. And we're a collaboration between Munster Technological University, working with Carberry on the dairy farmer side, Barry Rowe on the pig farmer side, GRASSA, who are represented here today by Johan, and UCD, whose work on the project will be represented by Bridget. So in the project, we demonstrated it's a bioeconomy project. So there is a focus on touching into those areas that Mark mentioned. It's focused on biological resources and trying to increase the sustainability of those, but also to look at what new products and particularly sustainable products we could produce from our biological resources. And in our project, we focused on demonstrating a small scale grass biorefinery. We did this with farmers in the 4 West Cork co-ops as part of the Carberry group. It's a mobile unit, it's a 2 ton per hour prototype, and we demonstrated that on 5 different farms. The purpose of that was, on one hand, to familiarize farmers with the operations involved in a bioeconomy process, specifically this grass biorefinery process, and also to involve them in the different logistical aspects of that and improve visibility of the bioeconomy and this particular system among the farming community. And on the other side, to try and produce enough volume of products that we could actually test and see how the products performed, and did this have a realistic chance of being an opportunity for diversification into the bioeconomy. So within the process, we take in fresh grass. The grass is washed at the start, and it's mechanically pressed using an extruder to separate out about 35%, 40% of the protein into a pressed juice, which can be further processed, and the remaining protein remains in fiber, a dry fiber fraction, which can be ensiled and can be used as a ruminant feed. From the pressed juice, then we can apply heat treatment to concentrate the protein, which can be separated using a solid liquid separation, can be dried and can be used as potentially as a feed for monogastrics. The residual stream that's left we call a grass whey, which can be processed using a membrane separation technology to extract out short chain sugars, fructooligosaccharides, which can be used in the feed additive or food and nutraceutical markets. And the final stream, which is a high liquid stream, can be further concentrated to produce a fertilizer, or can be used directly as a substrate to produce biogas through anaerobic digestion. So I'm going to talk a little bit about some of the trial work that we did on the different products that we produced. First of all, the first product we looked at was press cake, which we looked at as a replacement for silage in dairy cows. And Bridget is going to focus her presentation in on this in more detail, so I'm not going to talk too much, but I will say that we got very good results, even though the overall protein level that was in the press cake was lower than the silage. And because we got really nice results, it kind of opens the door to what we can get from this fraction here, the green juice fraction, when we extract further products, and that's what I'm going to focus in on. So as I said, we were able to extract a protein concentrate from the grass juice, and we were able to trial it as an additive in pig feed diets to replace soybean and other ingredients. We did this through a farm down in Cork owned by Cathal O'Donovan, a pig farm, and we tested it over a 31-day period with 55 weaners, 9-week-old, in each batch, and tried to include about 15% of the grass protein concentrate into a treatment diet and compared it to a traditional weaner diet for weaners of that age. So just if you look at the crude protein, it's about 34%, the crude fiber is about 6%. We integrated this into the diet, and we were able to take out about 30% of the soybean meal in the diet, in the traditional diet, about 25% of barley, and about 8% of the wheat. We ran the trial and we looked at the daily feed intake, and as you'd expect for weaners of that size, the daily feed intake in both samples increased week on week. But by the time we got to the end of the trial and the end of the period, we actually had an increase in daily feed intake in the case of the treatment diet, which is the diet which included our grass protein concentrate. We had a similar level of feed conversion ratio between the two samples. And in relation to the average daily gain, during the first week, we had a bit of a lag in the treatment diet because the pigs were most likely acclimatizing onto the new grass protein diet. And as the trial progressed, that started to improve week on week. And by the time we got to the end of the trial, we actually had an increase in average daily gain comparing the treatment diet with the control diet. So these are preliminary results. We've covered them in a publication, which I've included in the slide. They're preliminary results and would probably need further trials to further validate this, but it is, at least initially, a very positive indication of the potential of the protein. So just to look at the residual streams that are left, because we've extracted the press cake, extracted the protein, we then have the whey stream, which we can actually further valorize and extract this yellow material here, which is short chain fructooligosaccharides, which can be a prebiotic. So I guess what's a prebiotic? So we know what probiotics are. They're these what we call good gut bacteria that can grow in the intestines and can have improved gastrointestinal functionality and can have a lot of added effects, including removal of pathogens and alleviating and mitigating against different conditions. So fructooligosaccharides are one form of prebiotics, and prebiotics are the food that probiotics thrive on, that probiotics grow on. So they can come from multiple sources, fructooligosaccharides that can come from chicory, from artichoke and other plants, but there is the potential to extract these FOS from grass as well. So using a membrane separation technology from the residual stream, we were able to separate about 10 grams for every liter of whey of what we call a FOS concentrate, or a fructooligosaccharides concentrate, and about half of this was in the form of actual short chain FOS sugars. So to assess the potential of the FOS sugars, we did some lab scale work using a culture called a technique called cell culture, where we used the FOS to grow the probiotic bacteria to understand the potential for increasing cell density as a result of the addition of the FOS sugar. And we were able to compare these with other samples of FOS, including commercial FOS on the market, as well as inulin, which is often seen as the gold standard for prebiotics. And overall, we had very positive results across all of the probiotic bacteria. In particular, we had a very good comparison between the grass-based FOS and the commercial FOS. And while it's an early stage work, it does give an indication that there may be possible to get this value-added product from grass in the future. Then the residual stream that was left, we wanted to assess the potential of this to use as a substrate for anaerobic digestion, because we hear a lot in Ireland about the potential for grass to gas and to develop biomethane as an alternative use for grassland. So what we're trying to assess within the project as well is to understand to what extent we could extract some value-added products like protein, like FOS, like press cake, and still have some residual streams that could be used for the production of biogas or biomethane. So we did some work with our industry partner, Cygnus Analytical, on a lab scale to look at the potential of the side streams to be used for the production of anaerobic digestion. What we found was that overall, on a volatile solids basis and dry matter basis, we had a very good level of production comparable with silage for both the biogas and biomethane. It's quite a bit lower when we look at the fresh weight, which you would expect because of the products that we've pressed out of the grass, but it had a positive from the point of view of retention time. It was a very easily digestible material. We had about 80% of the biogas produced within the first 5 days, which is significantly shorter. So we think it could be implemented and upscaled without too much technical difficulty. And it does have the potential, if combined with CHP, combined heat and power, to meet most of the energy demands of the biorefinery, which would be positive from the sustainability point of view as well. So those are the main streams that we looked at. And Bridget is going to go into the press cake. But before I finish, I just want to mention the farmers who we couldn't have done this project without. So the dairy farmers who participated: Vanessa, Kevin, Michael, Tim and Shane, and Cathal and Declan, who participated on the pig feed trials. And we couldn't have done this without them. And I don't think we can have a bioeconomy without the participation of farmers, because it depends on the production of biological raw materials. So if we're to have a sustainable, long-lasting bioeconomy going into the future, we need to think about how farmers are going to be part of that. And I think one of the focuses of the Biorefinery Glass project was to really try as much as possible to put the farmers front and center, improve farmer knowledge of this. But going forward, I do think it's important that we make sure that these new business models that are being developed, if they're to be sustainable, they need to have farmers at the core. So a big shout out to all of our farmers, and that's all from me. And I'm passing back to you, Mark.
Thanks, James. So we're going to move swiftly on to Bridget's presentation. So Bridget is going to present now. So hi, Bridget.
Yeah.
So looking forward to having a good discussion afterwards. So do send us your questions using the Q&A tab at the bottom of the screen. And we can see your screen now, okay? We can see presenter mode, I think. So display settings, yeah, and just do swap, isn't it?
Yeah. Okay. So thank you, James, and I'm going to present the dairy feeding trial that was completed with the press cake on behalf of the team at UCD Lyons Farm, where the work was conducted, and a special thanks to the master's student on the project, Eleonora Sierra, who completed the work. So I'm going to start off with the baseline forages that were used in the feeding trial. So James explained how the press cake was produced. And it's important to note that the press cake was produced between the 1st of July and the 7th of August 2019. And the farmers had set aside paddocks for the biorefinery, and the machine was a little later getting to the farms than planned. And so the standing crop was more mature than we would have liked. We compared the press cake to a first cut grass silage that was produced in Lyons Farm, and that was mown on the 14th of May, had a 24-hour wilt, and so had, you know, as good a conditions as you would plan for first cut silage. So that's important to note when we look at the chemical composition of the feedstuffs that we used. So in combination with the maturity differences in the standing crop and the refinery process, the press cake had a higher dry matter percentage, a lower crude protein, higher fiber fraction. So those of you not familiar with chemical composition of feedstuffs, the NDF is nutrient detergent fiber and the ADF is acid detergent fiber, and just tells us the fiber fractions that are in the feedstuffs. And another one to note is a slightly lower phosphorus content in the press cake compared to the first cut grass silage. So we took those forages and we formulated 2 experimental treatments to work with lactating dairy cows. So our control or a grass silage treatment consisted of 14 kilos of the first cut grass silage, 7.2 kilos of concentrate on a dry matter basis, and there was also 440 grams of soya in the diet as well. The press cake treatment had 5 kilos of grass silage, and there was a direct substitute of 9 kilos of press cake for 9 kilos of grass silage. Same level of standard concentrate, and then the soybean meal was added into both diets to make sure that we met the protein requirements for the cows for the stage of lactation and what they were producing at the start of the trial. And these were fed in a partial mixed ration. So the grass silage press cake, half of the concentrate, which was an 18% dairy ration, and the soybean meal were fed in the partial mixed ration, and then the cows received the other half of their concentrate in the parlour at morning and evening milking. So the cows that we used, so we selected 30 autumn calving Holstein Friesian dairy cows from the commercial herd at Lyons Farm, and they were 70 days in milk at the start of the trial, producing 31 kilos per day at 4.3 and 3.7% fat and protein respectively. They had 2 weeks essentially to adapt to the feed treatments, and then we measured, or the parameters that I'm going to present on were measured over a 63-day period. And those measurements included dry matter intake, milk production and composition, rumen fermentation parameters like pH, ammonia, and volatile fatty acids. metabolic status, and we also completed a nitrogen and phosphorus balance as well. So this is the chemical composition of what the animals actually consume through the dietary treatments. So again, just the press cake remained to have a higher dry matter percentage compared to the grass silage, a lower protein, higher fiber fraction, and also a slightly lower phosphorus content. And it's just important to note those as I go through the results. So just starting with intake. So the cows ate the press cake, no problem. They did have a lower part and mixed ration intake and total intake compared to the grass silage groups, as you see there, and that was significantly different. And because of that lower intake and also the lower protein content in the treatment and a slightly lower phosphorus content, they also had lower nitrogen intake and phosphorus intake. There was no difference in feed efficiency, and feed efficiency in this context is energy correct milk divided by dry matter intake. So moving on to milk production and quality, and milk production is shown in the top half of this table, and milk quality is shown in the bottom half of the table. So we've no significant effect of treatment on milk yield, on protein kilos, and there is a tendency towards a reduction in milk solids production in the press cake group compared to the grass silage group. And that is driven by a significant reduction in fat kilos produced per cow per day on average during the experimental period. With regards to milk quality, there was no significant effect on fat or protein, but a numerical difference there on fat, which is probably driving that reduction in fat kilos produced per cow per day. A reduction in milk urea in the press cake group compared to the grass silage group, and also a reduction in energy corrected milk in the press cake group compared to the grass silage group. So other findings from the measurements that we took during the animal feeding study. So what I'm showing here, the arrows are press cake versus grass silage, and these were significant effects. There was a reduction in rumen ammonia concentration of the protein or nitrogen that the animals consumed in the diet. There was more excreted in milk and feces, and there was no difference in urinary nitrogen. And that's important because urinary nitrogen is volatilized much more readily compared to fecal nitrogen. And we obviously want to see more of the nitrogen diverted into milk and feces. There was an overall reduction in nitrogen and phosphorus excretion, and there was an increase in nitrogen use efficiency in the press cake group compared to the grass silage group. So just moving on, Eleonora also completed an in vitro study with the rumen simulation techniques. So this is essentially a lab-based rumen. So what we've got here is a number of vessels that represent individual rumens. We collect rumen fluid from dairy cows and put it into the vessels. And that essentially the rumen environment is simulated in the laboratory through a heated water bath. We have saliva that's been pumped through to keep the rumen or the vessels buffered. And these are fed every day with the feedstuffs or the experimental feedstuffs that we would have given the real cows, if you like, to simulate the same treatments and the same environment. So from that, we can collect the overflow into the collection containers down here. And it also enables us to collect gas that is produced from the rumens as well, or the vessels as well. And just to credit Megan Bach, who worked on the project, for putting together that nice diagram. So we looked at the same two dietary treatments that I explained already, and over the 8-day experimental period, we're able to collect or estimate apparent digestibility, pH, in vitro fermentation parameters, in vitro total gas, and methane production as well. So the findings from the RUSATEC study, and these are trends towards, so they weren't significantly different, but they are interesting nonetheless. There was a reduction in apparent digestibility, a reduction in rumen ammonia concentration, which mimics what we saw in the cow trial, a reduction in total gas production, and also a reduction in methane production. So this reduction in apparent digestibility probably isn't entirely surprising given the fiber levels in the feedstuffs in the pressed cake compared to the grass silage. So to conclude, pressed cake has the potential to partially replace grass silage in the diet of early lactation dairy cows. And I think if we can target, harvesting the feedstuff or the grass, just as it's about to head out at more vegetative stage, then I don't think you would see a difference in the performance of the animals. There was a reduction in nitrogen and phosphorus excretion and an increase in nitrogen use efficiency that shows the potential, I guess, for environmental mitigation through the use of pressed cake. And Johan is going to expand more on the nitrogen use efficiency and protein replacement. And I guess the next steps with regard to research would be to look at a higher quality standing crop and also look at the inclusion of grass clover swards and multi-species swards to improve feed quality, but also to reduce the nitrogen or chemical nitrogen that's used in the system, which will help the life cycle analysis further. And Lawrence, as part of the Farm Series E project, Lawrence Chalou is starting a trial with pressed cake, and he is going to be putting the cows through the green feeds. And so there will be methane emission work coming in the next couple of months from the Farm Series E project as a follow-on. That's it from me.
Okay, thanks, Bridget. That's gives a very good assessment of the animal digestibility side of things. A few questions coming through there on your presentation. We'll come to those at the end. So we now move to our final presentation, which is from Johan. And Johan, I'll just send you a link there to start your video as well. Can you, yep, that looks good.
Yes, I would like to start with the bigger picture. We use...
sorry, Johan, to interrupt you. If you could maybe maximize your screen there,
yeah.
Go to full slide presentation mode.
We use far too much nitrogen to make our daily protein, and we have too little land to do that. 2/3 of our agricultural land in the world is used for animal feed. And at the efficiency level that we use nitrogen to make the 50 grams of protein that we eat per day, we need about 7 kilograms of nitrogen to get 1 kilogram in the protein. And with 10 billion people in 2050, we would need more than 3 times the amount that our planet can cope with. These are the planetary boundaries. Everybody is aware of the CO2 and the greenhouse gases, the biodiversity losses, but also the nitrogen already has overstepped the planetary boundaries. Protein could become scarce in the world if we do not solve this problem. We will get a lot of biodiversity loss. We will get misharvest after misharvest that could lead to hunger, that could lead to wars, and a lot of migration from people that do not have enough protein. So we could use less nitrogen in agriculture. We could make more protein per hectare. We should increase not only the use of the nitrogen, but also the protein that is produced in agriculture. Sometimes is lost in agriculture. We should use that. And of course, we should reduce the amount of transportation that we require, and the farmer income should also be higher. There are several solutions, main solutions. So shifting towards a more plant-based protein in our food, or growing feed crops, at least on land that is not suitable to grow food crops because they are required for human food. Enhancing the fertilization efficiency of crops using legumes, and those are plants that can fixate nitrogen from the air in a form that you can produce proteins in the plants. And of course also recycle ammonia from manure digestate, because then you can better direct and control the use of the nitrogen, which is now not very easy in manure. Biorefinery can help us to have a higher benefit of the proteins grown in plants. I will show you about that, and James already did. Improve the digestibility and also the feed conversion. And what would be a good crop for choice? Of course, it's under our feet, grass, most common in the world, and certainly also in Ireland. And if you compare grass or grass clover, which is actually a legume, with other crops, for instance, like soybean, you see that the protein yield per hectare already is quite a lot better than for soy. And also some essential amino acids, which is important for monogastric animals, is also important. It's a perennial, so the whole year you can harvest the grass, and you could also use it in arable farming as a perfect rotation crop. As James already has mentioned, we can produce now 4 different fractions starting from grass. One is the press cake, which has an increased protein resistance, which is a benefit for the feeding to ruminants, to cows. We make a protein concentrate, a dried protein concentrate, which has 55% dry matter and a better essential amino acid composition than soy. So this has a higher value. We make the prebiotic that James already mentioned, and a mineral concentrate that can be used in agriculture as a fertilizer. I show you now the process as it is in the Netherlands at 4 tons of fresh grass per hour. Here you see the refiner that opens up the cells, and you get the press cake here in the end. And here below you see the juice, which is transported. Here we do a filtration step for the protein. Here we do a coagulation by heating, and then the protein becomes insoluble, but still very wet, as you can see here. Most is water. But down the line of this vacuum press filter, it becomes more drier and drier. And here you see protein leaving at a concentration of 20% dry matter. And afterwards, it is dried in a separate dryer. I should go to, When we look to the sustainability and compare grass protein with soy meal protein, we use a lot less land. We have lower emissions of ammonia and phosphorus. And also the greenhouse gases are a lot lower when we compare to soy produced in Brazil. As a consequence, we do not require any import of soy protein in the European Union anymore. If 25 million of hectares, which is about a third of the grassland in Europe, and Ireland could play an important role, could be processed, as I indicate, so that we compensate for the import of soy. It is non-GMO, which sometimes is regarded as an advantage. It will increase the employability per million hectare with about 100,000 FTE. And the production of grass, of course, can be done on marginal land. And Ireland could become a net exporter of protein products and prebiotics. When I look forward quite a bit, if we combine different technologies, as I mentioned, to use legumes in swards, we need a lot less nitrogen fertilizers. The biorefinery will increase the protein efficiency and making about 50% more animal protein, while the milk per hectare stays at the same place. So all the 50% added is protein from pigs or poultry. And we could strip about 50% of the ammonia in manure digest states. And if we combine that, starting with a efficiency use of nitrogen of 16%, combining that with all the different technologies that I mentioned, we could threefold increase it, or a little bit lower if we don't combine all three technologies. But this threefold would make us that we will stay within the planetary boundaries. Another outlook, and some of you will recognize this slide from last week's Signpost event. We are now in an Irish project, Farm Zero Carbon project. We have a holistic approach. We see that we do the carbon sequestration. We have the biorefinery, we have biogas production, and a variety of other technologies, electricity from wind, in order to reduce the different types of CO2 emissions, animal emissions, also from land, and hopefully it will result in the overall reduction of emissions of CO2, which is now a little bit more than 1 kilogram of CO2 per kilogram of milk. And gradually we hope to reach zero emission of CO2 in the end of this project. Overall conclusion is that biorefining of grass will increase the animal protein production per hectare by about 50%. Biorefinery of leaves can substitute all soy imported in the European Union and can make Ireland a net protein exporter. And biorefinery will lead to increased rural employability and increased agricultural incomes. Thank you for your attention.
Thank you, Johan. And I mean, that really puts it into context, the importance of these types of projects, given the reliance of the EU on imported protein. I was just looking at some figures there. I think about 14 million tons of soybean is imported by the European Union annually. So which is a huge amount coming from outside of the bloc. So we have some questions coming in here, but just before we get to those, and maybe Johan, if you could stop sharing your screen for us. Oh yeah. We talked about that overall. Obviously, this science is at we would say you've prototyped it, so forth. What about the economics of this? Has that been looked at? And I'll maybe throw it out to whoever wants to take that one, because it is a question I imagine that comes to mind for people as to how scalable is this type of technology.
Yeah, well, we had this topic, of course, also in the glass project that James was referring, also in combination with biogas. That is a good combination, because then you make the energy that is required in the process yourself from renewable resources. And overall, it came to a positive economic result. That's also the case in the Netherlands, where we now have 4 tons per hour, but we plan next year to go to 8 tons and probably also to 16 tons. And that certainly gives you a good payback in the order of 4 years or something like that of the capital that you require to do this. And of course, labor and energy costs are all included. As I mentioned already in my presentation, we are not only isolating the proteins and the fibers, etc., from the grass, but we are also upgrading them so that the market value of these products will increase. And that will make us that it even can be done at smaller scales than 8 tons per hour. But we think 8 tons per hour is still, in a country where there's a lot of grass, It's a few kilometers to the left, a few kilometers to the right to collect enough of your raw materials.
James, if I could ask you in relation to the, I suppose, the overall involvement of farmers in these types of projects, initiatives. This is something that we have spoken, I think, even last year at last year's Bioeconomy Week, about the importance of farmers being involved in or having some ownership of this process, because something like this could so easily, I suppose, be farmed out or up the value chain. Has there been any thinking done around that in terms of, you know, the potential for cooperatives to form around these types of technologies?
I think it's over the last few years, it's definitely come more under the spotlight from the policymakers' point of view. There's an initiative at European level called Bio-Based Industry Joint Undertaking, which is working to help commercialize the bioeconomy, biorefineries across Europe. And really they're placing a greater emphasis on the need for a better integration of farmers within these large scale demo projects that are going to get funded, because there's a significant amount of investment that's going to be required to roll this out. And for a business to operate over a 25, 30-year period, you're going to require farmers to be providing that feedstock all the way along, not for the first few years, and then something else comes along. So I think there is a growing realization that the models need to include farmers in, for example, as you said, a cooperative way in order to help achieve this. I think that's what we've been trying to do to some degree within the project. And with the GRASS model, as Johan said, because you have a very high moisture content material, you probably have a more local supply chain. And if you can get the value from the products, then you have a smaller facility. You have potential for farmers to come in as potential shareholders in this, because the capital expenditure from some of the larger scale facilities that we see across Europe could be avoided. But as you said, there is still a risk that large industry runs away with all the opportunities. And I think it's important that that doesn't happen.
And Bridget, from an animal feed perspective, how do you think that this type of technology will be received by the industry, given the reliance on imported protein sources?
Yeah, I think there's a lot of interest in, I suppose, the idea of producing our own protein. And, you know, there's a lot of work underway in protein crops, you know, peas, lupins, things like that. But not everywhere can grow those. So if we could produce a protein concentrate that can be used both in monogastric and also ruminant diets from grassland, which grows in 90% of our land area, and that it can support a similar level of production compared to soya or the alternatives that we import at the minute, then I think that would be hugely welcome.
I was fascinated by the diagram you showed there. I was feeling sorry for the poor soul, whoever had to collect the saliva for that experiment. Or was that something that was actually generated artificially?
No, the saliva is artificial, okay. But the rumen is real, and they have to collect that, and it's all under license. Yeah. Of course, yes.
Padraig, some really interesting questions coming through there.
Absolutely, Mark, and plenty of them. Johan, just out of curiosity, if I can ask a question myself, how do you see it working? So you said there are obviously a lot of grass fields to the left and to the right of the plant. Would they be consistently producing grass just for your plant, or would they be kind of just bringing in first cut silage and then getting back the pressed cake afterwards in wraps? Or like logistically, how does it work? Are they just harvesting for the process?
Well, the best, of course, economically speaking, is that you have 12 months a year your raw material available. So in countries like yours itself, at the warm Gulf Stream, you have a benefit over the Netherlands, where we have cold winters, and 3 months we do not have grass. But in that period, we want to process vegetable residues, for instance. And we also look into other countries. In France, we can produce the whole year around. Not only grass. Next week I will go to Uganda, where they have a lot of legumes. other plants than grass. And they are very good for producing the protein because they start with a higher protein level in the leaves. So there's a variety of raw materials, but of course, economics tell us 12 months a year gives a better return.
There's quite a few questions on the economics of it and what the cost would be for a commercial system. Even you mentioned 16 tons, but even at the current 4 tons per hour or 8 tons per hour, what an estimate approximately what would it cost to set up a system like that, and when would it be commercially available?
Yeah, we expect that the 8 tons per hour will cost between 1.5 and 2 million euros. So quite a bit, but it is 3 times a potato harvester, I would say. So it's quite a bit. The economy of scale will tell us that at 16 it will be somewhat better, of course.
Okay. Bridget, the DMD of the press cake, just a question on that and what it was.
Yeah, so we analysed dry matter digestibility by calculation in the laboratory, and I wasn't happy with the results. I've actually just queried them. So Eleanor is going to look at that again, but through the RUSTEC study, the apparent digestibility of the grass silage treatment versus the press cake treatment. So with all the feedstuffs in it, there was a 12% difference. So press cake treatment was 12% lower in apparent digestibility.
Did you look at the volatile fatty acids in what you were working with, or was there any difference in vitro or in vivo?
Yeah, so that's a good question. Just for maybe those unfamiliar, volatile fatty acids are a major end product of the digestion of carbohydrates in the rumen, and so are a logical thing to measure to get all the pieces of the puzzle together to explain, I suppose, the milk production and what's happening in the rumen. So we did measure those, and they've just been analysed in the lab, and Eleanor's just got them back this week. It was delayed because of just access to the lab with COVID. So we have those, and they are the final measurement before we submit a paper or publish on this work.
James, does it have to be fresh grass that you use, or can you use silage? Just like, obviously, Johan mentioned that you can work with different vegetable crops and so forth, but from an Irish perspective, you have a tight window for harvesting.
Yeah, so it's ideally fresh grass part, but you can't run a system on 6 months of fresh grass a year. So when we looked at the economic model, we based it on 280 days, and we had 180 days of fresh grass and 100 days of silage. We took into account in the mass balance that we did some initial processing at GRASSA's labs. The quality of the products isn't as good when we look at silage. The protein concentration is lower, the FOS production is lower. So we took that into account in the economics. So it's possible, but we need to have that extra feedstock, but it isn't as profitable as the 6 months where we have fresh grass or other materials, sugar beet leaves or other materials that could be available. Johan, I don't know if you want to elaborate on that.
No, that is the case. And the loss in the protein content in the protein product can be recovered in the FOS concentrate. Even while the FOS is somewhat lower, you will collect all the other peptides from the protein in that membrane fraction.
We just have a question in relation to, you mentioned about the planetary boundaries, Johan, in your presentation. Have you looked at the environmental, or the overall environmental impact of taking, say, 1 kilogram of press cake, and how energy intensive is the biorefining process? So I suppose maybe expanding that, and I know you have mentioned in the presentation, but thinking of those wider impacts.
Yeah, well, the process certainly takes quite a lot of energy. At the moment, that is diesel, but we want to use renewable energy, which can be done like the wind or solar energy. With solar panels, we need about 5% of the grassland that is being processed to raise the energy, enough energy for the whole process. And if we have biogas in place, we can cover about 2/3 of the biogas input from the leftovers from the grass process. So that is then coupled in each other. The overall picture is what I have shown to you: 75% reduction in greenhouse gases as compared to soy from Brazil, including all the deforestation. If we compare it with soy from the United States, it is, well, about 40% better. So still quite considerable. The other points not often taken into account: land use. As I showed, 33% lower land is required, and land of marginal quality that you cannot use for arable crops, and you should appreciate that in Ireland and in other countries, of course, as well. And well, the output of nitrogen and phosphorus is also considerably lower. And that is important to stay within the limits of this planet.
Bridget, there was a question coming in there around whether it would justify pressing a farm's full winter feed supply, or would you treat it as being the best route for what's now going into surplus bales? Yeah, so that's kind of a question, if you're happy to take that one.
Yeah, I suppose I kind of see this fitting into a farm system as being something for a fragmented farm where you've outside land blocks, and you could use maybe, you know, a couple of hectares that are away from the yard for this, and maybe target, you know, the type of grass species that are in it and the timing of cutting for that. I suppose if you're looking at surplus bales, it would depend on how it's set up, maybe in a co-op system in the area, and the supply, or what kind of contract you would have with the biorefinery. You know, if it's surplus bales, it's a bit ad hoc and it's very much open to grass growth in a particular year. The winter feed stuff, I think we would need to run another trial on a higher quality standing crop before we could be sure that the press cake could fully substitute for grass silage for the winter period.
We have a question here from one of our viewers, just asking about us to talk about vegetable protein for food. I guess this project has been developed in the context that there will be livestock production for the foreseeable future, and that this is part of that process of reducing the environmental impact of livestock production. I mean, Johan, we know that there are, you know, a lot of developing countries now are looking to increase the amount of meat in their diets, and you know, that this is something that we can't necessarily control centrally or at a global level, but we do need to come up with these bottom-up type approaches that you're presenting. Maybe you'd like to comment on that any further?
Yeah, I'm just writing a publication at the moment. Also for the Netherlands, it's an issue. But I think we should reduce our animal protein in our diet. But it doesn't say that we need to reduce the animal protein production in our country. And the same could hold for you. We should export more of our animal products to other countries, because in our countries, you cannot produce a lot of arable crops on that same land. What we might do is isolate the protein from the grass, or better from legumes. And technically it can be done. We did it, and we can make even white protein, so that people are tending to eat it without getting green teeth, things like that. It can be done, and it will be done in the future, but you have to get permission from the European Union for that, and that takes a lot of time and money.
James, where do you see the next stages of this project going?
Well, I think Denmark is one of the leaders in this space at the moment. They currently have 3 demonstration plants commissioned. I focused on technology that they've been working on up there, but quite similar to what we've been demonstrating, and it's been backed heavily by the dairy industry as being one of the sustainability plans in the future. So I'd like to see something like that happening in Ireland, potentially a demonstration facility that we actually have based here that people can see, because I think it's so replicable that if you did have one successful model, it could be something that could be replicated regionally across the country. And when we talk about the bioeconomy, you know, grass is such a key part of that from an Irish point of view. So I think this could fit in very well. So it's hard to know whether it'll be industry-led, maybe on the protein side. Whether it'll be farmer-led coming together is still unclear at this point. I do think when you look at the protein industry side and the fact that so much around imported soybean is coming under the spotlight over the last number of years. You had Marks and Spencer's last year putting plans in place to reduce imported soy for ingredients in their products coming in from Brazil. And there's been other companies in the same position over in the UK that I do think is going to come more and more under the spotlight, and this could potentially resolve a lot of challenges there.
James, is there any move to do any research on the beef side, even with suckler animals?
Most of the work so far has been on the dairy side, both here in the Netherlands and in Denmark. I think it should happen, and I think there's definitely, even though the projects have predominantly happened in the dairy sector so far, there's definitely an element where everyone involved feels that there's a role for beef farmers in this as well.
Yeah, I think the beef farmers, they could produce the press cake that is unbaled, and they can sell that to the dairy farmers. Then the dairy farmers do not need to make their own silage for the winter, and they could have more cows per hectare during the season, and that could help both the beef farmers as the dairy farmers.
Johan, what would you seem to have a pretty good global perspective on things. What do you think would be grown where the soy is currently grown in Brazil? Will they move to more grassland then and produce more beef, or what would you think could happen in that situation?
Oh no, soy is not just grown for the protein, but it is grown for the oil as well. And actually the soy protein is a side product from the oil industry. Therefore the prices are low and it's difficult to compete with it. But as I said, with 8 tons per hour, we think we can compete with the soy protein. Also because we have a higher concentration of protein in the end product. Brazilian soils, well, they have to be used for arable soil, arable crops, like there are many of them.
And another question for yourself, Johan, in relation to, you quantified the amount of soy that's imported and that this process could replace that. Do we have enough grassland available across the EU to do that, or have you quantified the grassland on a per country basis to?
Yeah, in the European Union, there's about 100 million hectares of arable land, good land, of which about 1/4 is used for feed with grass. There's about 70 million hectares of grassland in the European Union. Not all get enough water, but there are some places where they get enough water. And certainly half of that 70 million hectare is very good for this biorefinery purpose.
We have a comment in here that somebody's already offering to work with you on the beef side. So that's positive. Do we have time, Mark, to get a comment from the panelists in relation to wildlife? Just the impact of this process on it?
Yes, yeah, absolutely. Yeah, we have time for one more question.
Just guys, if you'd like to comment on the impact of the process on wildlife or biodiversity and how it can play a role.
Yeah, well, it will have, when you grow grass, it will not change it on the grassland itself. But in the zero carbon project that we are now running, we have a lot of attention for biodiversity, having hedges, counting all the different animals that we see, birds, worms, things like that. So that is on the micro level in the country itself. But if we do not need to deforestate forests in the rest of the world to get our feed, our feed and food, that will have an enormous benefit for keeping the biodiversity at high levels. I go to Uganda next week. In 1950, they had 5 million inhabitants. Now they have 40 million, and they hope to welcome a number 100 million in 2050. So a 20-fold increase in a century, which means the country is not much bigger per inhabitant than the Netherlands, that they will have serious problems to get their food and feed. So we have to work on a much better economies for the use of land, for the use of nitrogen, and otherwise there will be enormous problems with getting a lot of people, millions of people to Europe to get their food.
Okay, there we must leave it. Bridget, James and Johan, thank you so much for your presentations today. And I certainly really enjoyed. I mean, look, it's novel technology. It's something we need to be looking at areas like this to reduce the environmental footprint and to extract more value from what we're already producing from the land. So I think it's a fantastic example of that. So thanks again, and Padraig, thanks very much for helping with the questions today. Just a reminder to everybody that today's session is recorded and will be available on the Teagasc website. And next week we'll be speaking to Edward Burgess, who will be talking to us about fertilizer trends in Irish agriculture. Just a reminder to say thank you to our series producer, Andy Boland, and Yvonne Maher and Pat Murphy. And we'll see you all again next week at 9:30. So until next week, enjoy the long weekend, and we'll chat to you next Friday. Thanks again.
Bye. Thanks.
Bye.